Welcome to this deep dive, powered by Twin Labs. Today we're plunging into a topic that's, well, it's rapidly redefined the boundaries of artificial intelligence. Agentic AI services.
Yeah, it really is. We've been spending some time with a pretty comprehensive guide on this, specifically an article from Twin Labs titled Agentic AI Services, a comprehensive guide in 2025. It really maps out this next wave.
And why it's so different, right?
Exactly. It explains why it's, fundamentally different from what many people think of as AI today.
Absolutely, because when most of us think AI right now, it's often systems that react, isn't it? You give it a prompt, you get a response.
Right. Or you give it an instruction, it performs that specific
Like a
task.
chatbot answering a question or a system running a report when you click a button. Agentic AI, though,
Yeah.
that seems to move beyond that entirely.
It's a huge shift, a really pivotal one. We're not just talking about tools that sort of passively wait for commands anymore. Agentic AI refers to systems that operate with a significant degree of autonomy. They don't just respond to input, they actually act proactively.
Proactively. Okay.
Yeah, and they make decisions independently based on how they understand the environment and their goals. And crucially, they actively pursue those goals.
So that's the core difference then, the initiative, the goal-driven action.
That's it, precisely. They perceive their environment could be digital data, sensors, whatever process that info, decide what's the best action to take next.
Without being told step by step.
Exactly. And then they execute those actions, all with the aim of hitting some predefined goal.
Yeah.
And they learn as they go, adapting their strategies in these, dynamic settings.
Okay, so the mission for this deep dive is really to pull apart what that means, drawing directly from this Twin Labs guide. We want to get to the heart of what agentic AI actually is.
How it stacks up against other AI we know.
Yeah, and where it came from, the history. Then sort of peel back the layers, see how it works under the hood.
Explore the benefits, obviously, but also look honestly at the challenges, right?
Absolutely. The challenges, and maybe speculate a little on where it's all headed, the idea is for you, listening, to walk away feeling genuinely informed.
Not just about the buzzword.
No, about the substance,
Oh,
about this, well, transformative technology.
Think of it like getting a clear handle on something that's really set to reshape how businesses operate, how whole industries function.
And maybe even how we use digital tools every day.
For sure. It's about moving from just using AI to having AI that can work alongside you or even for you to achieve specific outcomes.
All right, let's unpack this then, starting with that fundamental question. What exactly is agentic AI? You said it goes beyond reactive AI.
Yeah.
How does the guide define that leap?
Well, the guide is very clear. The main distinction is moving past that traditional, prompt-based or reactive model. Most AI systems we interact with day to day.
Outside of maybe some heavy industrial stuff.
Right. Outside of certain automation, they operate on that principle. You give explicit instructions, they execute them. Agentic AI is a fundamental shift in how they operate.
So it's not just doing one task when told, but maybe initiating and managing a whole sequence of actions to hit a broader goal without constant human guidance.
Exactly that. The core definition in the guide is intelligent systems operating with a high degree of autonomy.
Autonomy.
Yeah, and that autonomy means they aren't waiting for constant instructions at every single step. They perceive their environments, state digital streams, sensor data, user interactions, whatever it is.
Okay.
They interpret that context, they weigh up potential actions against their goals, and then they decide and execute a course of action.
And they do this independently. That independence sounds like the critical differentiator.
It absolutely is the key. They pursue goals you might set at, say, a high level, but they figure out the steps to get there themselves.
Sure.
They make decisions based on what they perceive, their past experience or training data, and the goals and constraints they've been given.
And this happens even when things are changing, like in dynamic environments.
Yes, often in unpredictable environments where conditions are constantly shifting. The guide uses a helpful analogy here, actually. Thinking of agentic AI like a digital twin.
A digital twin. How does that analogy work? I usually think of those as just models.
Well, yeah, imagine a digital twin as a living, dynamic replica of a physical system or maybe a process. And agentic AI, in this analogy, isn't just passively mirroring that system.
It's more active.
Exactly. It's like a system that exists within that digital environment and can act inside it based on its understanding and goals. So if the digital twin detects a problem,
The agentic part could decide to do something about it.
Right. It might autonomously decide to take action within that simulated world or even a connected real-world system. It's about a system that perceives, understands, and acts within its operating space. It mirrors the complexity of actually operating in the real world.
Okay, that analogy helps a lot.
Right.
It's not just reflecting reality, it's proactively engaging with it.
Precisely. And this capability brings what the guide calls a new dimension of intelligence to AI. It's moving closer to mimicking human-like things like initiative, problem solving.
And handling complexity.
Yeah, exactly. They don't just process data, they use data to inform purposeful action.
Okay, so that defines the what. Now, the guide breaks down the fundamental capabilities of these agentic AI services into what it calls the three core pillars. These sound like the building blocks that make this new intelligence possible.
They really are. To truly get the power and implications here, you need to understand these foundations. The guide identifies three: autonomy and decision-making, goal-oriented behavior, and human-like adaptability.
And they work together, presumably, not in isolation.
Oh, absolutely. They're deeply integrated, interdependent. You can't really have one without the others working effectively.
Okay, let's start with that first one. Autonomy and decision-making. What does that mean in this context? It sounds straightforward, but I bet there's nuance.
There is. As the guide defines it, autonomy here is the AI system's ability to operate and take action independently. Critically, without requiring explicit human input at every single step.
Not just running a script, then.
Definitely not. It's about interpreting a situation, understanding the context, evaluating various possible actions, and then selecting and executing the best one on its own initiative.
So it sees what's going on, figures out what needs to happen for its goal, and autonomously finds the best path.
You got it. Think of it like giving it a high-level mission, and the AI is empowered to devise and execute the tactical plan to get there.
How does it actually do that, technically?
The guide touches on the technical side. It mentions integrating sophisticated AI planning algorithms. Those help map out sequences of actions.
Okay.
Then there's probabilistic reasoning techniques essential for handling the uncertainty of the real world. And of course, complex machine learning models that process all the incoming information and inform the choices.
What kind of information is it using to make these calls?
It's a mix, really, a synthesis of several inputs. First, environmental inputs, that's the real-time data the agent gets from its operational context. Sensor data, digital signals, user interaction.
Stuff happening right now.
Exactly. Second, it leans on its past experience or training data, the knowledge it's accumulated, which helps it predict outcomes or spot patterns.
Okay.
And third, the crucial bit, the predefined goals and constraints that have been set for it. These inputs are constantly being evaluated and reevaluated.
Can you give us a clear example from the guide, something that really shows this autonomy in action?
Yeah, the smart warehouse example is great. Imagine an agentic system managing logistics in a huge warehouse.
Yeah.
Its goal is simple: fulfill orders efficiently.
Okay.
It sees the environment using cameras, sensors, inventory data. Now, let's say it detects congestion in one aisle. Maybe a person is there, or another robot got stuck.
Something unexpected.
Right, an environmental input it wasn't explicitly told to look for, based on its goal efficiency and its knowledge of other routes from its training. It doesn't just stop and wait.
It decides what to do.
It autonomously decides to reroute its delivery robots or drones down a different path to avoid that bottleneck, all to keep the overall goal of efficient fulfillment on track. And the key part, that decision and action happen without a human jumping in at that moment.
That really highlights the speed and responsiveness.
Yeah.
What other benefits does the guide list for this level of autonomy?
Well, the guide points out several key advantages. Speed is a big one. Tasks get done way faster without waiting for human decision loops.
Makes sense.
Scalability is huge. One agentic system can manage and optimize tons of simultaneous tasks across a massive area, way beyond what direct human oversight could handle.
Right.
Responsiveness is better because it adjusts instantly based on real-time data. And all this adds up to significant cost efficiency.
How so?
By reducing the need for constant human monitoring and intervention, especially in routine or predictable, but still complex, scenarios.
It's clear autonomy isn't just a feature, it's a fundamental shift in capability. It lets systems operate at a scale and speed that were impossible before. It's moving automation from just following scripts to, well, dynamic, intelligent action.
It absolutely is a game changer, which leads nicely into the second pillar.
Goal-oriented behavior.
Exactly. This seems intuitive, right? If they're acting autonomously, they need a purpose, a direction.
Yeah, otherwise what are they being autonomous for?
Precisely. This isn't just about reacting to a specific prompt. It's about being fundamentally designed and structured around achieving specific outcomes. This purpose-driven nature is core, like non-negotiable for agentic AI.
So they aren't just following steps A, B, C.
No, they have an ultimate objective they're constantly working towards, and they adjust their methods as needed to get there.
The focus is on the end result, and the agent figures out the best way.
That's it. So instead of telling it, write this email, attach this file, send to these people, an agentic system might get a higher level goal, like ensure the project update gets to all relevant stakeholders by EOD, minimizing disruption.
Okay, much broader.
Yeah. And the agent would then autonomously break that down, figure out who the stakeholders are, decide if email is even the best way or if another channel works better.
Like Slack or Teams or something.
Could be. Then draft the content, find the right attachments, figure out the best time to send it so it doesn't mess up people's calendars, and then execute the whole thing.
The examples in the guide really helped clarify this for me.
They're good, aren't they? Like the personal productivity agent. Its goal isn't just scheduling appointments. It's higher level, like organize your week to reduce stress and maximize focus.
So it might actually decline meetings for you.
It might.
Yeah.
Or suggest blocks of deep work time, all based on that ultimate goal. Or the e-commerce agent example. Its goal isn't just show products.
It's optimized the whole shopping journey.
Right. It considers not just your search term, but your budget, your deadline, your past preferences, and proactively guides you towards the best buy. It might even try to negotiate prices or find discounts autonomously to meet that implicit goal of get the best value.
That's a much more sophisticated, almost collaborative level of achieving a goal. How does the AI manage these complex goals internally?
The guide talks about using hierarchical goal frameworks, which is pretty essential for handling complexity.
Meeting.
You break down a big, high-level goal into smaller, more manageable sub-goals. Like the goal plan a business trip might break down into find flights, book hotels, schedule meetings, and so on.
Okay, logical steps.
And each sub-goal can then be pursued autonomously, but they all contribute to that main objective.
The guide also mentioned different types of goals, soft goals and hard goals.
Yes, it adds another layer of sophistication. Hard goals are the non-negotiables, the things that must be achieved, like make sure the deadline is met, no exceptions.
Yeah.
Then there are soft goals. These are more like preferences that influence decisions but aren't absolute must-dos. Things like minimize cost or prioritize fastest delivery. These might sometimes conflict.
So the AI has to juggle these, like cost versus speed.
Absolutely. This structure, with different goal types, allows the AI to perform strategic adaptation. It can negotiate trade-offs between competing soft goals.
Like, is saving $20 worth waiting 3 extra days for delivery?
Exactly that kind of calculation. But it always ensures the hard goals are met. So if the cheapest flight disappears, but the hard goal is travel on Tuesday, it switches strategies to find the next best option, even if it compromises the minimize cost soft goal a bit.
Understanding this goal-oriented part feels fundamental to grasping how these systems can be proactive. It gives the AI a constant sense of purpose.
Right. It lets it stay focused and adjust its tactics on the fly when things change or obstacles pop up. It's not just reacting, it's actively trying to shape things or its actions within things to reach a desired future state.
Which leads us perfectly to that third pillar, human-like adaptability. This is where they start to feel less like complex machines, maybe.
Yeah, this is where they feel more like learning entities. Adaptability is their ability to learn from their experiences, especially from the consequences of their own actions.
Like humans learn from trial and error.
The guide makes that exact comparison. It's not just about being trained once on a fixed data set. It's about continuous learning and refinement while operating in the real world or a simulated one.
What are the key mechanisms that makes this adaptability happen?
The guide details several crucial ones. Reinforcement learning is a big one. The agent acts, gets feedback, rewards or penalties, and uses that to learn which actions lead to better results over time.
Learning by doing, essentially.
Pretty much. Contextual reasoning is also vital. Agents assess subtle situational cues, time of day, users maybe emotional tone, network load, location, and use that context to adjust their actions.
So they're not just following rules blindly.
No. And critically, this involves continuous learning. Unlike many static AI models, these agentic systems are designed to update their knowledge, their models, their strategies over time as they get new data and experiences. They're not frozen after training.
The digital health agent example from the Twin Labs guide really nailed this adaptability point for me.
It's a good one. Imagine an agent helping you manage weight loss. Initially, it gives a standard diet plan,
Okay.
but then it watches your food logs, your exercise, how well you stick to the plan, your actual weight changes over weeks, based specifically on that real-world feedback, your feedback.
It doesn't just keep giving the same advice.
No, it learns what works and what doesn't for you. It adapts the plan, maybe suggests different meal times, different exercises, changes calorie intake based on the actual results it's seeing. It's constantly refining its strategy based on direct feedback.
Why is this continuous learning and adaptation so critical for agentic AI? What does the guide say?
It highlights a few key reasons. First, it's essential for effectiveness in unpredictable, real-world environments where things change constantly and you just can't pre-program for everything.
Right. The real world is messy.
Exactly. Second, it lets the agent learn individual user preferences over time, making interactions smoother, more intuitive, deeply personalized.
Gets to know you.
Kind of, yeah. And third, it leads to performance improvement over time without developers constantly having to manually tune it. The agent genuinely gets better at its job the more it does it and the more feedback it gets.
This adaptability really makes agentic AI dynamic and resilient, doesn't it? It means they can handle unexpected situations, learn from mistakes, and actually improve,
Yeah.
going way beyond fixed systems.
Absolutely. So it's the combination, the synergy of these three pillars acting autonomously, being driven by goals, and adapting continuously that makes agentic AI revolutionary. It's what's ushering in this new era of intelligent automation.
It definitely sounds like a major leap. But the article makes it clear this didn't just, pop into existence overnight.
Oh, definitely not.
Agentic AI is the result of decades of research breakthroughs. Let's trace that history. How did we get here?
It's a really interesting journey, actually. Shows how different threads of AI research kind of wove together over time. The guide breaks it down into several eras, moving from basic logic to these sophisticated agents.
Where does the story start?
It really kicks off back in the 1980s with the era of rule-based expert systems. This was one of the first serious shots at building machines that could mimic human decision-making.
Albeit in a very limited way, I imagine.
Very limited. They worked using explicit knowledge bases coded as if-then rules. Experts in a specific field, say medical diagnosis or finance, would translate their knowledge into these rules.
Like if symptom X and symptom Y, then condition Z.
Exactly that kind of deterministic logic. Key characteristics were that deterministic nature, same input, always same output, and they were very domain-specific.
I didn't learn.
No real learning capability. Any updates meant a human expert had to manually change the rules.
What were the main problems with that approach?
Well, inflexibility was a huge one. If a situation didn't perfectly fit the rules, the system often just failed or gave bad output.
Brittle, basically.
Very brittle. Scalability was also tough. Adding more rules could create weird interactions or contradictions. And they couldn't apply knowledge outside their narrow little box.
But they still contributed something important on the path to agentic AI.
For sure. They laid the conceptual groundwork for autonomous reasoning. They showed that complex decision processes could be represented computationally, even if rigidly, using things like rule-based decision trees. It was the first step towards machines making choices based on internal logic, not just calculations.
Then moving into the 2000s, we hit statistical machine learning. That felt like a real paradigm shift.
It really was a data-driven revolution. The focus shifted from manually coding rules to developing algorithms that could learn patterns directly from large data sets.
This is where we get things like SVMs, decision trees, early neural nets.
Exactly. Techniques like support vector machines, various decision tree algorithms, early neural networks started gaining traction.
What breakthroughs from this era were key for agentic AI?
Well, machine learning brought powerful pattern recognition. Systems could find complex relationships in data without explicit programming. Supervised, unsupervised learning allowed for prediction, classification, clustering.
Things that feel more like intelligence.
Right, and integrating Bayesian reasoning allowed systems to make probabilistic decisions, which is much better for handling the uncertainty you find in real-world data.
How did this specifically nudge things toward agentic systems?
Agents could now make decisions informed by data, not just rigid rules. They got some limited adaptability, mostly through retraining models on new data. It started moving AI beyond fixed logic towards making predictions and choices based on learned patterns, crucial for future autonomy.
So this era built the foundation for incorporating learning and data analysis into agents.
Precisely. A critical step from deterministic logic to probabilistic data-informed capabilities.
Then the 2010s. Deep learning, reinforcement learning. This feels much closer to the core of modern agentic AI.
Yeah, this was arguably the most transformative period for laying the groundwork for proactive agentic behavior, a lot of it driven by learning through interaction with environments.
Deep reinforcement learning, DRL.
Right. DRL emerged as this powerful technique where agents learn by doing things in an environment and getting rewards or penalties based on the outcome. They learn to optimize a strategy, a policy, to get the most rewards long term, basically through trial and error.
Like teaching AI to play complex games.
Exactly, or navigate simulations. And at the same time, there was lots of research into multi-agent system scenarios with multiple autonomous entities interacting, cooperating, maybe competing in a shared space.
What were some key innovations from this time? The guide mentions AlphaGo.
AlphaGo is a huge example, yeah. Showed DRL could master incredibly complex strategy games at a superhuman level. Algorithms like policy gradients, Q-learning became central for training agents. And research also advanced in how multiple agents could communicate and coordinate.
Why was this decade so pivotal for the idea of agentic AI?
Because it gave agents the critical ability to learn continuously through interaction with their world, not just from static data. They developed real contextual behavior, genuine adaptability, by experiencing consequences.
And simulations became important.
Hugely important. Complex simulations became these essential training grounds for trying out and refining sophisticated autonomous behaviors before you dare deploy them in the real world.
So this period really set up the technical and maybe philosophical foundations for systems that could be proactive, goal-seeking, and adaptive like we defined earlier.
It gave us the tools and the understanding for agents that could learn dynamic strategies, not just execute static ones.
Which brings us to now, roughly the mid-2020s. The guide calls this the convergence era, scalable agentic services.
This is where all that theory and research from the previous decades started hitting the real world, becoming practical, commercially viable. A bunch of major tech trends came together to make it possible.
It wasn't just one thing then.
No, it was a convergence. The guide points to huge leaks in computing power, the accessibility and falling cost of cloud infrastructure.
And LLMs, right?
Yeah.
Large language models.
Critically, yes. The breakthrough performance of LLMs based on transformer architectures. They gave agents unprecedented abilities in understanding context, language, complex reasoning, made it easier for them to interpret human instructions and environmental info at a much deeper level.
Plus other factors.
Yeah, the rise of low-code, LOO-code platforms made it way easier for businesses to customize and deploy AI agents without needing armies of AI PhDs. And the growth of open AI ecosystems helped different models and services work together, adding flexibility.
So a perfect storm of tech advancements made agentic theory practical.
Pretty much. This convergence led to agents with seriously boosted capabilities. We started seeing systems that could self-update their goals and strategies based on feedback, almost in real time.
And handled different kinds of input.
Right. Seamless multimodal interaction became feasible agents understanding text, speech, images, sensor data all at once. And crucially, these systems could finally be deployed and scaled rapidly across loads of different areas: healthcare, logistics, finance, education, you name it.
This really marks the shift from agentic AI as a research concept to agentic AI as a deployable service.
It's the maturation point. It's the blend of autonomy, continuous learning, and sophisticated intelligence that can operate independently and at scale. That's what makes them relevant for businesses and individuals today.
This whole historical journey really is a story of technological synthesis, isn't it? Ideas from rule-based systems, statistical modeling, interactive learning, all merging and getting amplified by modern computing and large models.
To create intelligent agents that don't just process information, but truly perceive, reason, learn, and act.
Moving from rigid rules to these dynamic, goal-driven autonomous services capable of complex adaptation, it's quite a journey. Gives you real appreciation for the layers of innovation involved.
It really does. And speaking of layers, let's maybe dig a bit deeper under the hood now. How do these agentic AI services actually work internally? What's the architecture, the process enabling this dynamic autonomous behavior?
Yeah, the guide gives some insight into the core mechanics, right? It's not just a black box.
Definitely not. I mean, while they show this sophisticated, almost lifelike behavior, perceiving, reasoning, learning, acting with minimal human oversight, There's a pretty well-defined technical architecture and set of processes driving it all. Think of it like interconnected modules working together.
Okay, so what's the first module in this setup?
The guide usually starts with a perception layer. This is basically the agent's senses. Its job is to gather input from the environment it's operating in.
What kind of input are we talking about?
Well, for physical agents, robots, autonomous cars, it's sensor streams. Cameras, LiDAR, radar, GPS, maybe touch sensors.
And for software agents?
For software agents, it's about plugging into digital data sources, accessing databases, pulling info via APIs from other software, monitoring user interactions, processing digital signals.
And language,
Yeah.
if it interacts with people.
Crucial. Natural language processing, NLP, is a huge part of this layer for many agentic services. It lets the agent understand commands, questions, context from human language, spoken or written.
So this layer builds the agent's picture of its current reality, digital or physical.
Exactly. It takes all that raw input and converts it into structured representations that the other parts of the agent, the decision-making, the learning parts, can actually understand and work with.
Then comes a brain, right? The decision-making engine.
Yep. Described as the central control unit. It takes that structured data from perception, considers the agent's goals and current state, and figures out the best thing to do right now. This is where the intelligence really happens.
What's inside this engine? What makes it tick?
It usually includes components like planners' algorithms that map out future action sequences to reach a goal. It might have rule systems for applying specific logic or filters.
And handling uncertainty.
That's where probabilistic models come in. Things like Bayesian networks or other statistical methods. They're essential for dealing with the fuzziness of the real world, optimizing actions based on expected outcomes and risks, not needing perfect information.
So this engine is constantly evaluating. Given the situation and my goals, what's the most purposeful next step?
Yes, exactly. It ensures the agent's actions are purposeful, balancing things like efficiency, safety, effectiveness based on its current understanding.
And the third key module, that would be the learning part.
That's the learning layer. This is where the system evolves, gets smarter over time based on its experiences. It integrates those learning mechanisms we talked about earlier.
Like reinforcement learning.
Precisely. RL is central for learning from the consequences of actions. But other machine learning techniques are in there too. Supervised, unsupervised learning to update the agent's internal knowledge, refine its pattern recognition, maybe find new insights in the data it sees.
The guide mentioned meta learning too, learning to learn.
Yeah, that's a more advanced concept. It helps agents get better at acquiring new skills or adapting to entirely new tasks or domains more quickly. Helps them generalize faster.
So this learning layer is what gives the system its ability to continuously adapt and improve.
It makes it truly dynamic. It's not just running fixed code or static models. It's constantly refining its own insides to get better and more aligned with its goals as it experiences more.
Beyond just the modules, the guide talks about the actual reasoning and learning processes. How do agents make complex choices, predict outcomes?
Yeah, this gets into how that decision engine actually thinks, so to speak. A common technique involves decision trees and planning algorithms, not simple trees like the old expert systems, but more complex planning methods.
Like the agent exploring possibilities.
Kind of. Think of it mentally mapping out a tree where each node is a decision point, and the branches are the possible outcomes or consequences of taking an action.
So it's simulating potential futures, in a way.
In a sense, yes. It explores different action paths, weighs up short-term gains versus long-term consequences, and picks the path that looks most likely to hit its goal efficiently and effectively. The guide mentions advanced methods like Monte Carlo tree search, MCTS.
Used in games like Go.
Exactly. Used in complex strategy games and decision scenarios to explore a huge number of possibilities and find optimal strategies.
And this involves some kind of cost-benefit analysis.
Oh, absolutely. To make truly smart, rational choices, especially when resources are limited or risks are involved, agents do a form of cost-benefit analysis.
How does that work?
They calculate potential rewards of an action, weigh that against the cost could be time, compute power, energy, money, and assess the risks involved, like the chance of failure or bad outcomes. This leads to balanced decisions, which is critical in high-stakes areas like autonomous driving, medical support, or finance.
Where mistakes are costly.
Very costly.
And all this calculating and planning needs to happen fast, in real time.
That's essential for agents in dynamic environments. They can't just follow a fixed plan made ages ago. They have to constantly monitor changes, an obstacle appears, market conditions flip, a user changes their mind, and instantly update their strategy or replan.
That real-time adaptation sounds crucial.
It is for robustness in volatile situations like emergencies, navigating complex spaces, or responding to fast-changing user preferences. They use things like online learning and context-aware processing to make these immediate adjustments.
And none of this constant adaptation would work without feedback loops, right?
Exactly. Agentic AI systems absolutely rely on feedback. It's how they learn from successes and failures to continuously evolve and improve.
How does that feedback mechanism actually work?
The guide highlights the importance of continuous interaction. Unlike older AI trained in big, isolated batches, agentic systems are designed for real-time, ongoing interaction with their environment or users.
So they're always on, always interacting.
In a way, yes. This constant back and forth lets them see the immediate effects and downstream consequences of their actions and adjust their next actions accordingly. It makes their behavior much more fluid, responsive, maybe more human-like over time because they're learning as they do.
And they learn from different kinds of feedback, not just explicit rewards.
Right. Feedback can be explicit, like a reward signal in RL when a goal is hit, but it can also be implicit, derived from just observing. Maybe a user corrects the agent's output, or the system fails to achieve a sub-goal, or something changes in the environment showing a past action didn't work.
Positive and negative signals.
Exactly. Positive reinforcement for good behavior, negative for inefficiency or errors. All these bits of feedback are ingested, weighed based on importance, and analyzed by the learning layer.
And that analysis drives the recalibration, the optimization.
Precisely. As feedback builds up, the system uses it to refine its internal models, adjust parameters in its decision algorithms, maybe even refine its understanding of the goal's nuances. This might involve updating neural network weights, pruning bad strategies, adjusting decision thresholds. The whole point of this constant loop is to make the agent smarter, faster, more efficient, and better aligned with its ultimate objectives over time.
Wow. Okay, so diving into the architecture, the reasoning, the feedback loops,
Yeah.
it really shows how agentic AI manages to perceive, plan, adapt, and evolve autonomously. It's a complex interplay.
It really is. It shows they're much more than just complicated programs. They're sophisticated, dynamic entities built to learn and operate purposefully in complex, changing worlds. Understanding these internals is pretty key to trusting them and using them effectively.
Now, we've spent a lot of time on agentic AI, but we also hear so much about generative AI these days, systems like ChatGPT creating text, images, code. The Twin Labs guide makes a point of distinguishing these two.
Yeah, it's important because they are often confused, partly because they're both recent, high-profile AI advancements, but the guide clarifies their fundamental purpose and how they operate are really quite different.
The article lays out a comparison. Let's maybe walk through those key differences.
Okay. The most crucial difference is their core function. Agentic AI is designed to act with goals. Generative AI is primarily designed to produce content.
So one is about doing, the other is about creating. That's a neat way to put it.
Exactly. Think about the examples. An agentic AI's purpose is to perform tasks autonomously to achieve an outcome, manage a calendar to cut stress, reroute logistics for efficiency. A generative AI's core purpose is to generate novel content based on a prompt, write an email draft, compose music, create an image.
And their autonomy levels reflect that difference.
Totally. Agentic AI, by definition, has high autonomy. It makes independent decisions, takes initiative towards its goals. Generative AI usually has low autonomy. It's mostly prompt-based, waiting for your explicit instruction before it generates anything. It doesn't have internal goals it's pursuing when it writes text, other than just fulfilling the prompt.
And the learning methods differ too.
Generally, yes. Agentic AI often relies heavily on reinforcement learning action sequences through trial, error, consequences alongside supervised learning. Generative AI, especially the big foundation models, is mainly trained using huge amounts of data via supervised learning patterns, to generate plausible new content that fits those patterns.
It's interesting, though, the guide mentions potential synergy between them, despite the differences.
It does, and that's where things get really interesting for the future. While they have different primary jobs, combining them could create some seriously powerful systems.
How so?
Imagine an agentic system tasked with solving a complex customer support issue. It could use generative AI internally to craft really empathetic, personalized, clear communication responses as part of its overall goal execution.
So the agent decides what needs to be said, and the generator helps how to say it.
Kind of like that, yeah. Or an agent managing a research project could use generative AI to summarize dense documents or brainstorm initial outlines. The agent provides the purpose and the action, while the generator provides sophisticated creation abilities the agent can leverage.
So, to sum up the distinction, generative AI creates, agentic AI does. Different primary purposes, but potentially very complementary.
Understanding that difference is key to using each type effectively and not getting confused about what they can realistically do.
Okay, with that understanding of what agentic AI is, how it works, and how it differs from generative, the obvious next question is, why do we need it? What are the real tangible benefits these services offer, especially over traditional automation or even human processes? The guide outlines several key advantages.
Yeah, and these benefits are really what make agentic AI such a compelling technology for businesses and maybe even individuals down the line. One of the biggest is improved efficiency.
How does agentic AI drive that efficiency?
Well, because these agents manage tasks autonomously, no constant human supervision needed, no step-by-step instructions, they can drastically streamline complex workflows.
Faster executed?
Much faster execution than waiting for human reaction times. They can reduce errors that happen during handoffs between different systems or people,
Mhm.
and they dynamically optimize resource allocation in real time based on changing conditions. Think back to that smart warehouse rerouting example again.
And the result of that streamlined autonomous operation is?
Faster operations overall, significantly less manual overhead, and consequently real cost savings. The guide mentioning agentic bots automating complex, repetitive workflows in big companies, that's a prime example of this efficiency gain.
Another key benefit mentioned is enhanced personalization.
Yes, and this goes way beyond simple customization, like choosing a background color. Agentic systems can observe, learn from, and adapt to individual user behaviors, preferences, even their context over time. They build a much deeper understanding of the user.
Like the digital health coach example again?
Exactly. It personalizes the plan not just based on your initial answers, but on how you specifically interact with it and what your body specifically does in response.
That level of learning and adaptation allows for a much deeper personalization.
Which, as the guide points out, directly boosts user satisfaction and the overall effectiveness of the service because it feels genuinely tailored to your unique needs and how they change over time. The system is really working for you.
And the third big benefit, proactive task execution.
This one is maybe the most transformative compared to reactive systems. Agentic AI doesn't just sit there waiting for you to tell it what to do.
It anticipates.
It anticipates needs or potential problems based on its goals, what it perceives in the environment, and its understanding of the context. Think of that smart calendar assistant again. It doesn't wait for you to flag a flight delay.
It sees the delay notification itself.
Right. It monitors your travel plans, sees the delay, identifies potential meeting conflicts, and then takes action to reschedule those meetings autonomously, possibly, before you even realize there's an issue.
So it acts ahead of time, predicting and mitigating problems or maybe seizing opportunities.
Precisely. That proactive capability is incredibly powerful. It lets systems fix issues before they blow up, grab fleeting opportunities, just generally stay one step ahead. It reduces the cognitive load on us humans by managing all those complex interdependencies automatically.
Connecting these benefits back to you, the listener, maybe you're drowning in information, trying to juggle complex tasks at work or home, or just wishing your digital tools were less clunky. These benefits paint a picture of a future where tech isn't just a passive tool.
Right. It's more like an active participant that can handle complex stuff for you, proactively and intelligently.
It shifts the relationship, doesn't it? From just command and control to something maybe more like collaboration.
Yeah, significantly augmenting what we can do by handling the underlying complexity and execution.
Okay, but building these sophisticated, autonomous, goal-driven adaptive agents, that can't be simple. It needs specific tools, technologies, but also, as the guide stresses, careful thought about design principles and ethics.
Absolutely crucial. On the technical side, you need the right building blocks. Natural language processing, NLP, is foundational for many of these services, letting them understand and interpret human language. Vital for user interaction, processing documents, voice commands.
Basically, if it needs to work with humans or understand human instructions.
Essential. Reinforcement learning, as we've said, is highlighted as a cornerstone for achieving that real autonomy. It's how agents learn complex behaviors and optimal strategies through interaction and feedback, adapting in ways pre-programmed systems just can't.
And multi-agent systems.
Those capabilities become essential when you're dealing with complex environments where multiple autonomous agents need to coexist. Maybe they need to collaborate on a shared goal, or maybe they compete to optimize their own outcomes.
Like coordinating a fleet of delivery robots or managing resources in a smart factory where different automated systems interact.
Exactly those kinds of scenarios. Or even complex simulations where different AI entities represent various stakeholders. These are complex, multi-agent situations where coordination and interaction are non-negotiable.
Beyond the tech, though, the guide really emphasizes design principles and ethics. With systems acting on their own, responsibility is huge.
Hugely important. One critical principle is value alignment,
Meaning,
making sure the agent's goals and objectives are genuinely aligned with human values and what the designers and users actually intended. The guide explicitly warns that misaligned goals, even if they seem minor, can lead to really significant unintended, maybe harmful consequences when the agent pursues them autonomously and at scale.
you need to be really sure the AI's definition of success matches yours.
Exactly. Then there's trust and transparency.
How do you build trust with an autonomous system?
It's vital. It requires agents, ideally, to provide some level of transparency, to be able to explain their decisions or the reasoning behind an action when needed. This is super important in regulated sectors like healthcare or finance.
Where you need to know why an AI did something.
Right. Understanding why an AI recommended a treatment or made a trade isn't just nice to have, it's about accountability, compliance. Explainability builds trust.
And bias mitigation. That's a challenge across all of AI, right?
Absolutely. Agentic agents learn from data, just like other AI. If that data reflects historical or societal biases, those biases can get baked into the agent's decision-making.
Leading to unfair or discriminatory results.
Potentially, yes. So these systems have to be carefully designed and trained to spot and mitigate those inherent biases in their data and their logic.
So building these isn't just about plugging tech components together. It's a significant ethical and design challenge.
Ensuring they're aligned with human intent, transparent enough to trust, and fair in how they operate.
The importance of thinking about ethics right from the start of design. You can't really overstate that.
No, it's not an add-on. Building trust and ensuring value alignment isn't just good practice. It's critical for safe, successful, widespread adoption.
We've touched on examples like smart warehouses, health coaches, productivity tools. The guide reinforces that agentic AI is versatile. It's finding uses across many industries right now.
Yeah, its ability to perceive, reason, and act autonomously makes it useful wherever you have complex processes, dynamic environments, and goals to achieve. In healthcare, think agentic systems monitoring streams of patient data, proactively flagging early warnings based on subtle changes.
Catching things humans might miss.
Potentially, or just faster. In finance, managing complex investment portfolios, executing trades automatically based on market signals and risk rules.
Religious.
Optimizing entire supply chains, dynamically rerouting shipments, forecasting inventory needs, coordinating fleets of vehicles or robots in real time.
Customer service.
Agents providing contextual help, anticipating customer needs based on their history, proactively engaging to solve problems before they escalate.
The common thread, as we keep saying, is they act on information and goals. They don't just process or react.
Exactly. They take initiative within their domain to achieve some beneficial outcome.
And this capability is even changing something as personal as our daily productivity.
This is where many of us might start experiencing agentic tech without calling it that. Think advanced smart calendars. They don't just log appointments, they might autonomously reschedule based on conflicts, commute times, maybe even your energy levels if linked to health data.
Wow. AI coaches, too.
Yeah, evolving from generic advice to proactive career plans, fitness routines, mental wellness tips, all tailored and adjusted based on your progress and feedback.
And digital assistants getting smarter.
Moving beyond just setting timers. Executing complex workflows without needing constant prompting. Drafting detailed emails that need info from multiple places, booking tricky multi-stop travel itineraries, optimizing for preferences and cost, managing complex follow-up reminders across different apps.
So they're taking on entire processes for you, acting more like intelligent partners than just tools.
Precisely. Becoming more like intelligent companions, helping us navigate the complexity of the digital world, boosting productivity, and, importantly, reducing that feeling of digital fatigue by proactively managing tasks and information for us.
The potential is clearly massive, really exciting, but changing industries and daily lives with autonomous systems, it's not going to be without challenges, right?
Yeah.
The guide is realistic about the hurdles agentic AI faces.
Oh, yeah. There are definite challenges that need serious attention for safe and effective widespread use. One is straight-up technical limitations.
What kind of technical hurdles?
Well, while agents can be great within a specific domain they're trained for, getting them to generalize their skills seamlessly across totally different contexts, that's still really complex.
Building truly general-purpose agents is hard.
Extremely hard. It's still a major research challenge. Most successful agents today are still pretty domain-specific or need significant retraining for new tasks.
Then there's the huge issue of safety and unpredictability.
Paramount, especially as agents get more autonomy in complex, open-ended, or safety-critical situations. Autonomous actions can sometimes lead to unexpected, unintended behavior.
Especially in situations they weren't trained for.
Exactly. Or where multiple agents interact in ways no one predicted. Ensuring robust safety guarantees, predictable behavior across all possibilities, that's a massive challenge. Needs rigorous testing, monitoring, fail-safes.
And like any powerful new tech, regulations are a big factor.
Absolutely. Governments everywhere are trying to figure out how to govern AI, especially autonomous systems. New regulations, like parts of the EU AI Act, are demanding compliance frameworks, risk assessments, transparency, particularly for high-risk AI applications.
So ensuring legality, ethical use, public trust, it gets more complex with autonomous decisions.
It does, and the regulatory landscape is still changing rapidly.
So these challenges, technical limits, safety, regulations, they aren't necessarily stop signs, but more like critical areas needing careful research, development, policy work, and ongoing oversight as this tech becomes more integrated.
Exactly. They highlight the need for really responsible innovation. Collaboration between the tech folks, policymakers, ethicists is key.
But despite those challenges, the long-term potential described in the guide seems enormous.
It really does. The guide paints a picture of a future with agentic systems being far more integrated and capable. Next-gen developments are already looking at integrating emotional intelligence, allowing agents to respond not just to the words we use, but also tone, sentiment, emotional cues, making the interaction feel more nuanced, more human-like.
Adding another layer to that human-AI interface.
Yeah. Robotics integration is another huge direction. Putting agentic brains into physical robots that can navigate complex, real-world spaces, manipulate objects, make decisions on the fly out in the physical world beyond controlled labs.
And Edge AI.
Combining agentic capabilities with Edge AI, the ability for agents to make decisions locally, right on the device, in real time, instead of always needing the cloud, that boosts speed, privacy, resilience.
And the long-term vision the source suggests.
The guide floats the idea that by 2030, agentic systems might shift from being specialized tools to becoming ubiquitous digital coworkers.
Wow. Ubiquitous digital coworkers.
Yeah, implying a future where these systems are just seamlessly woven into almost every professional workflow and many parts of our personal digital lives, operating autonomously to boost human capabilities on a massive scale.
The vision really hits home the potential scale of impact this tech could have.
It points to a future where our relationship with technology is profoundly different. Less about manually driving tools, more about directing and collaborating with intelligent, autonomous partners.
For organizations, or even individuals, thinking about exploring agentic AI, the guide offers some practical advice, right? How to get started, what to look for.
Yes, it suggests a phased approach for businesses. First step, assess internal needs. Figure out where in your business or workflow agentic automation could make the biggest difference.
Like repetitive tasks needing complex decisions, or areas needing real-time responsiveness.
Exactly, or places where proactive management could add serious value. Understand where the pain points are that agentic capabilities could actually solve.
So identify the right problems first.
Right. Once you know the needs, step 2, choose the right platform or service. Look for vendors or platforms with strong core capabilities. Things like robust agent modeling, good NLP integration for natural interaction, real-time analytics to track performance, and the ability to handle complex decisions and adaptation.
And finally, pilot and scale responsibly.
Don't try to boil the ocean. Start with small-scale pilot projects in controlled settings. Test them thoroughly, get feedback on how they perform, and if they're actually meeting the goals, make adjustments. Then think about a bigger rollout. It's an iterative process.
And if a business is looking to buy these capabilities from a vendor, what should they evaluate?
The guide lists key criteria. Customizability is big. Can you easily tailor the agent's goals and behaviors to your specific workflows? Real-time feedback and autonomy. Does the system truly learn and act autonomously based on live data?
Multi-agent coordination.
Essential if your application involves multiple agents interacting. And non-negotiable. strong security and compliance support, especially if you're in a regulated industry.
The guide also listed some vendor examples, just as a snapshot.
Yeah, just as examples active in the space around 2025, it mentioned OpenAI Agentic Suite, Anthropic Claude agents, Google DeepMind agent services, and Cohere task-oriented AI, just giving a sense of the players.
And for most organizations, is it better to build these complex systems themselves or buy them?
The guide suggests that while huge companies with deep AI expertise might build custom solutions, most businesses will likely get more value, faster, by buying pre-built agentic services and then customizing them. Buying is often quicker and more cost-effective than building from scratch.
Okay, that section provides really valuable, practical points for anyone thinking about how this tech moves from just a concept to actual use, whether in business or just out of personal curiosity.
Yeah, it helps connect the dots between understanding the what and figuring out the how of actually getting started with these capabilities.
Well, that was a truly extensive deep dive into the world of agentic AI services, drawing heavily from that comprehensive guide provided by Twin Labs.
We really covered a lot of ground. The core definition, moving beyond reaction to action with intent, making decisions, pursuing goals, those three pillars: autonomy, goal orientation, adaptability.
Right, the foundations.
Yeah.
And the history, too. That journey from rule-based systems to today's scalable services.
Yeah, and how they work under the hood: perception, decision-making, learning loops. We clarified the agentic versus generative AI distinction.
Important difference. And the benefits: efficiency, personalization, proactivity.
Plus the tools needed to build them, and those crucial ethical principles: value alignment, transparency, bias mitigation.
We looked at applications across industries, how it could change personal productivity.
And faced the challenges: technical limits, safety, regulations, while still looking at that incredible future potential, maybe even ubiquitous digital coworkers down the line.
The bottom line is, these systems don't just respond. They're designed to act with purpose, learn continuously, work proactively alongside us, potentially redefining intelligent automation and collaboration.
Definitely. Whether you're thinking about this for your business, wondering about its impact on your industry, or just curious about the next AI frontier, understanding agentic AI really gives you a crucial lens on the future of technology.
And that brings us to a final provocative thought for you to consider. As our digital tools shift from being passive instruments waiting for our commands to becoming active, goal-driven participants that learn and adapt on their own, how fundamentally will our relationship with technology need to change? How do we navigate that balance between the huge potential for efficiency and augmentation they offer and the absolutely essential need for human oversight, understanding, and ensuring their actions stay aligned with our complex, often nuanced human values day in and day out? What new landscapes of collaboration, trust, and responsibility will this create in our work and our personal lives?
Powerful questions, ones we'll definitely be grappling with in the coming years.
Thank you for joining us today. Visit the Twin Labs website for more business insights.